This is the proposed code for sentimental analysis. The dataset I have used is Twitter dataset of airline sentiment. You can download the dataset from this link. First of all, I have imported the basic model such as NumPy, Pandas, multiprocessing and string. Next, I have imported NLTK for natural language processing. Now, I have imported some basic visualizing library such as Matplotlib and Seaborn. In the next piece of code, I have imported the model I have used, which include random forest, Gaussian NB, multinomial NB, logistic regression, and SVC. In furthermore, I have read the data using pandas library and saved this data in data frame tweets. Now I have copied the tweets data frame into dataset. Now I have shown the attribute airline sentiment. Here we can see that the number of negative tweets is much more than the number of positive and neutral tweets. So clearly this dataset is unbalanced. This dataset is furthermore divided into 6 more datasets which include the Virgin America, United Southwest, Delta, US Airways and American. In next piece of code, I have removed the unused value from the data frame, which include tweet location, tweet ID, airline sentiment confidence, user time zone, negative reason code, name of the user, tweet created, tweet coordinate, and retweet count, negative reason confidence, and negative airline sentiment gold. Further, I have shown the bar graph for airline sentiment. In next piece of code, I have pre-processed the data which include first of all removing punctuation as they are not that important for sentimental analysis. After removing punctuation, I have tokenized the data. After tokenizing, I have removed stop word which include is, am, and other stop word in English language. Furthermore, after removing stop word, I have removed the word on the basis of length. After removing the word on the basis of length, I have stemized the list. The stemming is the process for converting the word into its base word. After converting, I have removed the first word of every text as it is the flight name only. After preprocessing, I have encoded the airline sentiment into numbers. So for negative, I have used 0. For neutral, I have used 1. And for positive, it is 2. After handling the text data, I have detokenized the text. After detokenizing, I have shown the most visualized, most repeated word. So we can see that the frequency of unit airways JetBlue flight and services is more than the other words. After visualizing the frequency of word, I have applied the vectorization to the text. After vectorization, I have handled the imbalanced dataset. For, for balancing, I have used S mode with oversampling the data. After, after handling the imbalanced dataset, I have splitted the data into two parts which include training, training dataset and testing dataset. The size of test dataset is the one third of whole dataset. After this, I have wrote a function which generate the report of the machine learning model I have used in further piece of code. So the first model I have used is Naive Bayes, which gives the accuracy of 83%. And this is the confusion matrix of Naive Bayes. In further piece of code, I have shown the precision recall curve for Naive Bayes. This is the curve. The second model I have used is logistic regression, which perform much better than previous model, which gives accuracy of 85% in, and this is the confusion matrix for logistic regression, and this is the precision recall curve for logistic regression. Further, I have used random forest model for training our data. So the accuracy I have achieved by random forest is 83%, and this is the confusion matrix for random forest model, and this is the precision recall curve for random forest model. For better result, I have used SVM, which gives much better result than the previous three models. By using SVM, I have achieved the accuracy of 89%, and this is the confusion matrix for SVM. Okay, so this is the precision recall curve for SVM. After SVM, I have used SVM with grid search CV for much better result. By using this, we have achieved the accuracy of 91%, which is much better than the previous three models. This is the confusion matrix for SVM plus grid search CV model. In the last piece of code, I have compared the accuracy result using above three models. So by using Naive Bayes, we have achieved the accuracy of 83%. With logistic regression, we have achieved 85% accuracy, and by using random forest, we have achieved 83% accuracy. And by using SVM, we have achieved 89% accuracy, and in final model SVM with grid search, we have achieved much better accuracy of 91.4%. Thank you.